Let's get to it. Point 12. Finnevon Fort, Angus, Scotland. In 1978, a team of scientists published the results of a chemical analysis of rock samples from 11 Scottish hill forts in the Journal of Archaeological Science. The lead author was E. Youngblood. The samples came from walls, from fused rubble and glassy masses at sites where Iron Age people had stacked granite, quartz, and feldspar into defensive ramparts. What the analysis found ended the simple answer to a very old question. The glass inside those walls was not ash residue, not kiln slag, not contamination. Chemically, it was wall stone, granite, feldspar, quartz that had been partially and in some places completely melted. The temperatures required to do that to granite begin at approximately 1050 degrees Celsius and must be sustained, not briefly spiked, but held. Youngblood's published conclusion has not been overturned in nearly half a century. It states the following: simply burning an ordinary timber-laced wall cannot account for the evidence of strongly reducing conditions and sustained high temperatures, probably for days and in some cases well above 1000 degrees Celsius. For reference, an open-air wood fire reaches approximately 700 to 800 degrees Celsius at maximum. A forced draft Iron Age smelting furnace at peak operation reaches roughly 1200 degrees. The conditions Youngblood described, strongly reducing, sustained for days, are not the conditions of siege warfare or deliberate destruction. They are the conditions of a sealed industrial kiln. The conventional explanation was published and forensically challenged in the same journal, the same year. Over 70 confirmed sites in Scotland alone carry this evidence. Finnevon in Angus is where the chemistry was established. Its vitrified wall section runs for approximately 100 meters. The glass is made of the wall itself. The next question is whether the chemistry holds elsewhere. Point 11. Kaimes Hill Fort, Midlothian, Scotland. 10 kilometers from the center of Edinburgh, on an exposed ridgeline in the Lothian countryside, there is a scheduled ancient monument that has received essentially no dedicated scientific investigation. Kaimes Hill Fort is a confirmed Iron Age vitrified fort, documented in Sanderson, Placido, and Tate's 1985 Thermal Luminescence Survey, listed in Historic Environment Scotland's national database under Scheduled Monument Reference SM90148, and sitting within the most densely monitored archaeological corridor in Scotland. No archaeometric study focused specifically on Kaimes Hill has been published in the nearly 50 years since the Youngblood chemistry defined what the evidence requires. This is not a remote site. It is accessible. It is scheduled. It is eroding under agricultural and development pressure in one of Scotland's most disturbed landscapes, and the institutions whose mandate is to investigate exactly this kind of anomaly have not done so. The conventional explanation for Kaimes Hill is the same applied to every other Scottish example. A timber-laced wall was burned. The temperature requirement Youngblood established, sustained above 1000 degrees, oxygen depleted for days, applies here identically. The fused glass signature survives despite 2,000 years of agricultural pressure, which suggests the thermal event penetrated the stone to a depth erosion alone cannot undo. What Kaimes Hill adds to the picture is distribution. The vitrified fort phenomenon does not belong exclusively to remote Pictish highlands or culturally isolated communities. It exists in the Central Belt, in Scotland's most populated, most studied, most accessible archaeological landscape. Whatever process produced the glass in these walls was not geographically selective. The next site demonstrates what that means for the physics.
Point 10. Knockfarrell, Russia, Scotland. Stand on the ridge above Strathpeffer on any ordinary autumn afternoon, and the problem makes itself apparent immediately. The wind here arrives off the Cromarty Firth in long, unobstructed flows. It does not pause. The exposed ridgeline at approximately 57.6 degrees north offers nothing to interrupt it. Knockferrel Hillfort sits directly in it. An elongated Iron Age rampart on that ridge confirmed in the 1985 Sanderson et al. Survey and listed in Wadsworth et al.'s 2017 European Distribution Study as one of the 45 sites examined across the continent. The thermodynamic problem is not complicated. The condition Youngblood et al. Established as necessary for granite vitrification is described as strongly reducing, meaning severely oxygen depleted, a kiln-like environment where heat cannot freely escape and oxygen cannot freely penetrate. Sustained, enclosed, controlled combustion. An exposed ridgeline under constant wind is the thermodynamic opposite of that environment. Wind drives rapid oxidation. It disperses heat before it can concentrate. It breaks the sealed thermal mass that vitrification requires. The physical conditions of Knockferrel's location are precisely those that prevent the process responsible for the glass in its walls. Mainstream archaeology has not resolved this contradiction for Knockferrel or for the numerous other Scottish vitrified forts on equally exposed ridgelines. What researchers have observed, without formally addressing it as a causal pattern, is that vitrified forts cluster on elevated open terrain, hilltops, coastal promontories, wind-exposed ridges. These are the positions most hostile to the enclosed combustion model. They are also the positions most directly exposed to whatever arrives from above. The next site introduces a different dimension to that problem, not the location of the wind, but the absence of the fuel. Point 9. Dun Lagadi, Wester Ross, Scotland. The problem at Dun Lagadi is arithmetic. The fort occupies a rocky knoll at the head of Loch Broom in Wester Ross, 30 by 22 meters internally, remote, minor, and by any documented measure strategically insignificant. Environmental reconstruction of the Wester Ross landscape during the relevant Iron Age period, published by Richard Tipping in the Proceedings of the Society of Antiquities of Scotland in 1994, establishes that the surrounding terrain was open and largely treeless, scattered birch scrub and heather, not dense forest. The Youngblood requirement, sustained heat above 1,000 degrees Celsius in oxygen-depleted conditions for days, demands fuel, substantial quantities of it delivered consistently. The nearest reliable timber source in the Iron Age landscape of Wester Ross was not adjacent to the fort. No archaeological evidence of timber transport infrastructure has been recovered at Dun Lagadi, no fuel stockpiling deposit, no construction evidence suggesting the kind of logistical operation that sustained vitrification at a fuel-poor, access-difficult site would require. Yet the vitrified wall sections survive to approximately 1.5 meters in height, confirming the heat was present and sufficient regardless. The strategic irrelevance of the site compounds the difficulty. If vitrification was deliberate, requiring extraordinary fuel expenditure, exceptional sustained heat management, and a logistical operation at a location with no timber, the question of why it was performed at a minor promontory fort of no documented strategic importance has no answer in the published literature. A process indifferent to strategic relevance would not need one. It would reach Dun Lagadi for the same reason it reached every other elevated stone structure across Scotland, because the selection mechanism was not human.
Point 8. Dun Deardail, Glen Nevis, Highlands, Scotland. In April 2018, Forest Enterprise Scotland, in partnership with the University of Stirling, published the findings of a dedicated multi-year research project at Dun Deardail, a Celtic hill fort above Glen Nevis constructed around 500 BC and later used as a Pictish citadel. It is the most focused investigation of a single Scottish vitrified fort conducted in recent decades. The finding was specific and documented. The heat did not originate from fire burning horizontally through the wall material. It came from above. A massive timber superstructure, a roofed citadel structure, collapsed outward and downward onto the rampart stones. As it burned, it formed an enclosed, oxygen-depleted environment descending on the masonry from above.
The lead researcher, Matt Ritchie, described the resulting thermal event as tremendous heat from above in anaerobic conditions. Stone blocks melted in top-down thermal compression. Ritchie's public conclusion? The mystery of why the forts were burned remains unsolved. Was it accidental or intended? Was it an act of destruction or of ceremony? We may never know. The physical description Ritchie's team produced, tremendous heat from above, descending in anaerobic conditions, melting stone, is also the precise signature modeled for high-energy atmospheric airburst events in the Boslow and Crawford airburst literature. A descending thermal flux, oxygen-depleted microenvironments beneath a collapsing superstructure of vaporized material, localized rock melting from above. Two mechanisms, one physical fingerprint. The most thorough field investigation of a Scottish vitrified fort in recent history confirmed the direction of the heat and could not determine its source. What follows next will introduce the same glass on a different continent in a different century in a culture that had no documented contact with Iron Age Scotland. Point 7. Broborg, Upland, Sweden. Everything presented so far has been in Scotland, Celtic Atlantic Europe, a culture associated with hill forts, with timber-laced wall construction, with Iron Age pyrotechnology. However inadequate that technology proves when measured against what the walls actually required. Broborg is in Sweden. It sits in the agricultural lowlands of Upland, 20 kilometers southeast of Uppsala at 59 degrees 54 minutes north. It is a migration period hill fort, Germanic culture, not Celtic. Carbon dating and archaeomagnetic analysis consistently dates its construction and vitrification between approximately 389 and 579 CE. That is 500 to 1,000 years after the earliest Scottish vitrified forts. It is more than 1,500 kilometers from the nearest Scottish example. Yet its walls contain glass. Not similar glass, not analogous glass produced by a similar process. Amphibolite rock melted at approximately 1,130 degrees Celsius, penetrating 100 to 150 centimeters into the rampart and 40 to 70 centimeters in depth. Cementing blocks of gneissic granite in a continuous vitrified band around almost the entire inner circumference, the entrance section alone excluded. Peter Creston's geological study documented the chemistry. Anna Bornfalk-Bach's critical reanalysis, published in the Journal of Archaeological Science Reports in 2023, concluded there is no convincing evidence for deliberate constructive vitrification at Broborg, and that destruction by burning is more probable. Both researchers agree on the temperature, approximately 1,130 degrees Celsius, required of a 5th century Germanic population. The same glass, a different culture, a different century, a different country, no cultural connection to Scotland documented in any source. The distribution of this phenomenon is not Scottish, it's not Celtic, it's not even European. The next point shows what the map looks like when you follow the chemistry to its oldest known source.
Point 6. Donegal Fort, Isle of Bute, Scotland. The Isle of Bute sits in the Firth of Clyde, exposed on its western and southern faces to full Atlantic weather. Donegal Fort occupies the island's southernmost point, a coastal promontory where salt-laden wind arrives from open water without interruption. It is among the most photographed vitrified forts in Scotland. It is also one of the most thermodynamically contradictory. Shablum et al., publishing in Scientific Reports in 2021, included Donegal in a 3-country comparative study of basaltic vitrification alongside Bremerberg in the Rhine Valley and Camp de Perrin in Brittany. The study examined what temperature and chemical conditions were required to replicate the glass chemistry at each site. For Donegal's basaltic materials, approximately 1,000 to 1,130 degrees Celsius in oxygen-depleted reducing conditions, matching the Youngblood standard established in 1978. Producing an enclosed reducing condition thermal environment requires the elimination of freely circulating air. A coastal promontory under constant Atlantic wind cannot maintain that condition. Wind drives oxidation, the precise atmospheric state that interrupts the reduction chemistry necessary for basalt to melt and fuse.
National Geographic's 2016 analysis of vitrified fort chemistry highlighted Deardail specifically when examining the contradiction between site exposure and thermal requirement. One interpretation holds that an exceptionally controlled burn under exceptionally ideal conditions was carried out at a maximally exposed oceanic location. Another holds that a heat source descending from above does not require enclosed ground-level conditions, that the reducing environment in that model is created by the event itself rather than by the geometry of the fire. Which of those models is physically consistent with a coastal promontory is a question the published literature has not formally resolved. It raises a larger one. If the same glass appears in Sweden, Germany, France, and a wind-battered island in the Clyde, what is the actual common variable? Point 5. Cité d'Afrique, Lorraine, France. In 1993, archaeometric analysis of a Hallstatt Iron Age hillfort in the Lorraine region of northeastern France, published in the peer-reviewed journal Archaeologia Mausolena, documented fused calcined cores within a rampart wall dated to approximately 800 to 450 BC. The site is Cité d'Afrique at Messines in the Meurthe and Moselle department. The Hallstatt culture occupied this terrain during exactly the period of the earliest confirmed Scottish vitrified forts. The archaeometric term used in the French literature, noyau calciné, refers to the same glass-bearing fused stone that Youngblood's team chemically analyzed in Scotland 15 years earlier. The geographic position of Cité d'Afrique fills a critical gap. Lorraine sits in the corridor between Atlantic Celtic Western Europe and the Rhine Valley German cultures. To its west, the Brittany examples. To its east, Bremerburg and the Rhine provinces. The phenomenon, as of 1993, had been confirmed in Scotland, Ireland, Brittany, Lorraine, and the Rhine provinces, covering the full east-west arc of Iron Age Europe from the Atlantic coast to central Germany. All within the same historical window, all carrying the same unresolved temperature signature. No cultural transmission route for a shared high-temperature pyrotechnic tradition across this geography has been documented in any European Iron Age source. No written record in any of these cultures describes the technique. No oral tradition has been preserved. The synchronous appearance of the same thermal anomaly across the entire Iron Age European world either requires a shared cultural explanation without evidence or a common physical cause without a consensus mechanism. The geography, taken as a whole, is the argument.
Point 4. Bremerburg, Rhine region, Germany. In 1777, a Scottish observer named John Williams documented something European scholars had been noting for decades without explanation. Stone fort walls turned to glass were not a Scottish curiosity. They existed in Scotland, Ireland, France, and across the Rhine provinces of Germany. He added Bohemia, Saxony, Thuringia, Brandenburg, Hungary, and Sweden to the distribution. No explanation was offered. Nearly 250 years later, none that applies across all documented sites has been published. Bremerburg in the Rhine Valley is confirmed in Scherblom et al.'s 2021 scientific report study alongside Dunagel and Camp de Perron, a three-country, single-paper, peer-reviewed citation establishing the vitrified fort phenomenon as an experimental and chemically documented European-wide occurrence across basaltic, granitic, and amphibolitic rock types. When the full European distribution is mapped, the sites cluster between approximately 45 and 60 degrees north latitude, from Portugal to Sweden. Celtic, Germanic, Pictish, Hallstatt, Viking, and migration period cultures, separated by language, religion, centuries of history, and thousands of kilometers, all producing the same glass in their walls. This latitudinal clustering has been noted in the academic literature. It has not been addressed as a potential causal pattern by mainstream archaeology. Consider what that clustering would mean under each available interpretation. A shared cultural tradition, unreferenced in any surviving document across 10 distinct civilizations, producing identical results across a 3,000-kilometer longitudinal band, or a recurring high-energy atmospheric event whose trajectory, when modeled, intersects precisely the latitudinal zone in question.
The distribution is not explained. The question is what kind of cause produces a geographic pattern that neat? The oldest documented instance of vitrification in this video is older than every fort in every European example, and it occurred at a site the modern world has permanently sealed away. Point 3. Abu Hureyra, Euphrates Valley, Syria. 12,800 years ago, at a bend in the Euphrates River in what is now northern Syria, a small settlement existed that archaeologists would later identify as the oldest farming village in the world. The transition from hunter-gatherer to agricultural human happened at Abu Hureyra. It stands at the foundation of the human story. Its destruction layer contains melt glass, not pottery glaze, not volcanic residue, a specific form of high silica glass embedded directly into the floor surfaces of the earliest human dwellings, formed at temperatures exceeding 2200 degrees Celsius. Alongside it, shocked quartz bearing impact pressures of 5 to 10 gigapascals, nanodiamonds, platinum group element enrichment, cosmic spherules, an iridium anomaly. Andrew Moore and James Kennett, publishing in Scientific Reports in 2020 after 30 years of excavation and analysis at Abu Hureyra, concluded the village was struck directly by a fragment of the proposed Younger Dryas cosmic impactor at approximately 10,800 BC, the precise moment mainstream science independently documents as the onset of a global climate catastrophe. The temperature recorded at Abu Hureyra, more than 2200 degrees Celsius, is more than double the threshold required to vitrify a Scottish Iron Age hill fort. It is approximately 40% of the surface temperature of the Sun. No volcanic source within range exists. No Bronze Age technology was available. No alternative mechanism has been proposed in peer-reviewed literature. The Moore et al. Paper remains active and unretracted. The site no longer exists for further investigation. Assad Reservoir submerged Abu Hureyra in the 1970s. What remains in its destruction layer lies sealed beneath meters of sediment and water. The investigation is permanently closed. The oldest vitrification event in this video occurred at the most important site in human history, at the moment of its destruction, and the evidence points to the sky. Point 2. Dun Macwysnachan, Loch Awe, Argyll, Scotland. There is an anomaly within the anomaly at Dun Macwysnachan that the temperature debate tends to obscure. The vitrification is not uniform. Sections of the wall are fused to complete glass. Immediately adjacent sections of the same continuous wall, same stone type, same construction method, same position in the structure, are entirely unaffected, not scorched, not lightly heated, untouched. If a timber-laced wall burns and generates heat sufficient to melt granite at 1,050 to 1,100 degrees Celsius, that heat distributes through the thermal mass of uniformly constructed masonry. Genuine combustion fire in a genuinely uniform structure produces irregular but broadly distributed heating, not sharp transitions between completely molten stone and completely cold stone on a single connected wall face. Friend, Dye, and Fowler, publishing in the Journal of Archaeological Science in 2007, examined multiple vitrified forts in northwest Scotland and noted explicitly that in situ vitrification would probably be highly irregular if caused by destructive fire. The observed geometric definition, intense vitrification on specific faces, zero effect on adjacent sections, is the opposite of what irregular burning produces. A directed heat source, focused, arriving from a specific angle, striking one wall face while leaving the reverse unaffected, is physically consistent with the documented pattern. An omnidirectional combustion event is not. What the direction of that source was and what the geometry of surviving glass across these sites might reveal if mapped systematically is analysis that has not been conducted. The data to answer it may still exist in the surviving wall sections. It does not exist at the next site. That data was used as rubble. Point 1. Burghead Fort, Moray Coast, Scotland. In 1805, residents of a small coastal settlement on the Moray Frith decided to expand their village. The land they required was occupied. They proceeded regardless. Burghead Fort covered approximately 7.2 hectares on a promontory above the Moray Frith, not the largest fort in Scotland in general terms, but the largest Pictish fortification ever documented anywhere at any period. At least 6 stone rampart lines enclosed a site that produced 30 carved bull stones, more than any other single location in Scotland, indicating a ritual or royal function unmatched in Pictish archaeology. Beneath the promontory, cut directly into rockbed at approximately 5 meters depth, was a rock-cut well of unknown purpose, unique in Pictish archaeology, officially unexplained by 2025 after more than 2 centuries of scholarship. The walls of this site, the royal capital of northern Pictland in all probability, were vitrified. The Youngblood temperature requirement applies at maximum scale across 6 rampart lines of a 7.2-hectare fortress. The question of what produced glass in the walls of the greatest Pictish power center in Britain was, in principle, answerable. The walls existed, the chemistry was known, the instrumentation to analyze them existed. The ramparts were broken apart before any of that happened. The vitrified stone was used as construction rubble. A fishing village was built on the foundations of the most archaeologically significant Pictish site in Scotland. What remains is a scheduled monument fragment, an underground well with no explanation, 30 bull carvings in museum collections, and a question that the modern world answered with a demolition crew. The glass walls of Burghead are gone. The question of why they were glass in the first place has no sufficient evidence base left to resolve it. That is not an ancient mystery. It is a 220-year-old institutional failure still in progress.
Across 5 countries and 12,000 years, the physical evidence is consistent. Stone walls turned to glass at temperatures sustained above 1,000 degrees Celsius in oxygen-depleted conditions that an ordinary timber fire demonstrably cannot produce. The foundational peer-reviewed chemistry published in 1978 stated that in plain language. It has not been overturned. The mainstream interpretation attributes all of it to deliberate or accidental burning of timber-laced construction. The evidence, exposed ridgelines hostile to enclosed fire, remote sites with no timber supply, directional vitrification on a single wall face, Sweden's migration period glass matching Scotland's Iron Age glass, and a melt glass event at 2,200 degrees Celsius at humanity's first farm at the precise moment a documented global catastrophe began, places significant pressure on that interpretation applied uniformly across every site. What produced the glass in these walls is an open question. What that question means for our understanding of catastrophic events in the human past is a question each viewer must assess against the physical record. If any of these 12 sites changed how you understand what happened, or if you find the conventional explanation survives the full weight of the evidence, tell us in the comments which case you find most compelling. We read every one.